All right, good morning. Today we're going to do some notes on degrees and radians. This is a new camera, so it's kind of funky. So I'm sorry if it is being weird. I'm just trying to get used to it. So, like I said, we're going to talk today about degrees and radians. What are radians and how do we convert between them? All right, so degrees and radians. So, first of all, I guess we should decide what is a radian. So it's a unit of measurement that allows us to work with units and all sorts of different things and kind of get everything onto the same page. So if you picture a circle with a radius r, then anywhere you draw from the center to the outside, there is a radius r. So what a radian is the angle measure when the arc length is the same as the radius. That is 1 radian. So when the angle or the arc length is the same as the radius, when they're the same distance, then the angle measure is 1 radian. Okay, a couple other little bits and pieces that go with radians. And I'm sorry, this camera is very slow, so I'll just try to slow down. So 1 full rotation is equal to 2 pi. Because if the radius is 1, the circumference of a circle is 2 times pi times the radius. So 1 full rotation around a circle has a measure of 2 pi. Now think about that with regard to our coordinate plane and what we've been doing so far. So far, we've been using that 0 to 360 degrees being a full rotation. 90, 180, and 270 being the other kind of access points. But in radians, a full rotation is 2 pi. So it's either 0 or 2 pi here. Well, if that's the case, if this is 2 pi, then this would have to be just pi, right? Doesn't that make sense? It's half of it. And thinking the same way, if this section here is 1 pi, then wouldn't 90 have to be half of pi, or pi over 2? And similarly, we have 1.5 pi's, so 3 pi over 2 here. And that's going to begin to show you how degrees and radians coordinate. All right, so same parts of the axis if you picture a circle going around, but different way of measuring. And one more little piece before I show you how to use some of this stuff is to find the degrees in radians, or the measure in radians. A radian, the angle is equal to the arc length over the radius. So this formula will tell us how much of a radian we have. All right, and you have to be sure that your units are the same. All right, so let's do a few examples using this formula, and then I'll show you how to convert from degrees to radians. So if we want to know, we have a radius that's 10 centimeters and an arc length that's 2 centimeters. If we want to know the measure in radians, so theta, but in radians, we're going to use this formula, S over R. So that would be 2 over 10. Simplify. It is 1/5. radians. Now think about that. If 1 full radian is when the radius and the arc length are the same, then it makes sense that when the arc length is smaller, then it's that fraction of a radian, 1/5. All right, you should pause the video in a second and try this one, and then unpause and come back. All right, welcome back. So hopefully you already have this done, and I'm just going to write the steps. We have 4 inches over 22 inches, which is going to be 2/11ths of a radian. So that is how you do it when you are just trying to figure out how many radians it is. And you might be interested, just for a second, I'll just point it out, we don't have to write it down, to see how many degrees 1 radian is equal to. So if 1 radian is 180 and pi, they're the same. 180 divided by pi, about 57 degrees per radian. Okay, so we have pi for this and 180 for this. All right, let's convert. So we're going to convert between degrees and radians. All right, remember, a full rotation is either 360 degrees or 2 pi radians. All right, so that's going to help us convert. So to go from degrees to radians, or we're going to go from radians to degrees. The formula for degrees to radians is that we're going to take our degrees, our theta in degrees, and multiply it by pi over 180. Because radians typically have pi in them, and so you need to get pi into it that way. The other way, if we want to get degrees, it's equal to the radians and the reciprocal, 180 over pi. And you'll see in a minute that that makes a whole lot of sense, because that is how we're going to cancel out the pi from the radians. So let's do a few examples of that, and then we'll call it a day on this topic. So we're going to go from degrees to radians. We're going to start with 30 degrees. All right, so all we have to do is multiply from degrees to radians. We're going to multiply by pi over 180. I like to simplify in the problem, so you can kind of imagine that over 1 maybe, if that helps you. And then I'm going to simplify across, so that's going to be 1 and 6. So 30 degrees is the same as pi over 6 radians. All right, you try this one. 75 degrees. Pause the video and put that into radians, and then unpause and check. All right, hopefully you did this. We're going to multiply by pi over 180 to convert. We will simplify. Okay. And multiply through 5 pi over 12. If you understand the process of converting, but you're having a hard time with simplifying, let me know and I'll help you with that simplifying process. But I think you should be fine. All right, now we're going to go from radians to degrees. We're going to start with 7 pi over 12 radians. So again, in order to convert from radians to degrees, we're going to multiply by 180 over pi, which makes a whole lot of sense, because look what we can do. We can cancel out the pi, which is perfect. And we can simplify our, oops, that should be 15. I don't know why I put 5. We can simplify our our fraction, and then we multiply. 7 times 15 is 105 degrees. So 7 pi over 12 is equivalent to pi, or 105 degrees. All right, number 6, you try this one and then come back and check your answer. We're going to do 2 pi over 3. All right, pause and go ahead. All right, welcome back. Remember, when we're converting this way, our pi is in the bottom, so we can cancel it. We're going to simplify and multiply it back through. So 2 pi over 3 is equal to 120 degrees. All right, that's that for degrees and radians. Have a good day.